Assalamualaikum. So I hope everyone's are doing okay. So basically we have 2 more chapter left dan kedua-duanya melibatkan kebanyakannya melibatkan calculation. Okay, we will do lots of calculation. Okay, so in case you have any question, so feel free to ask me through GC or Telegram. Okay, shall we start? But first, let me close this video first. Okay, so where's my pen? Okay, so I'm going to explain to you today chapter 8, which is chemical equilibrium. But before that, let's have a look at types of chemical reaction. So we have 2 different types of chemical reaction. The first one is reversible. Second one is non-reversible reaction. So for reversible reaction, for example, okay, we have this orange juice, for example. When we freeze in the freezer, so what happened? The juice will become the ice cream. Means that the states of matter change from liquid to solid. And when you heat this ice cream, it will change back to liquid form. However, the chemical properties still the same. Maksudnya, bila even dia dah jadi ice cream, dia masih sifatnya orange juice. Cuma dia berubah daripada liquid to solid. So this process is reversible reaction. Okay, so basically reversible reaction is a chemical reaction that proceeds in both forward and reverse reaction. So for reversible reaction, the symbol is anak panah like this, half-headed arrow, patah balik. Okay, that is reversible reaction, means that orange juice can turn into ice cream, and in different temperature, this ice cream, okay, will melt into liquid. So the process is reversible. Next is a non-reversible process. So for example, this mold, okay, mold, when we add it into the bacteria, so what happen? Kita hasilkan, boleh hasilkan cheese, yogurt and so on. So once kita dah hasilkan this product, boleh tak kita nak jadikan dia sebagai susu semula? Impossible, right? Okay, so maksudnya this process is non-reversible. Means that chemical reaction proceed in, this one, in forward reaction only. So when reactants are used up, the reaction will stop. Symbol for non-reversible reaction is like this. From left to right, fully headed arrow. Okay, another example of non-reversible is telur. Okay, telur. Okay, telur, then you goreng. You goreng dalam suhu 100. So what happen? You will have telur mata. Betul tak? Okay, now let me ask you. Boleh tak telur mata nak jadi telur yang asalnya balik? Cannot, right? So the process is non-reversible. So throughout this chapter, we will be talking lots of reversible reaction. Okay, so you guys can refer to Google, tengok jenis-jenis reaction lah. Okay, now let's have a look at dynamic equilibrium. So now we are going to focus on the reversible reaction. For example, hydrogen react with iodine gas. Okay, it will form hydrogen iodide. And hydrogen iodide ni, dia boleh dissociate into these two gas. So maksudnya the process is reversible. Okay, both forward and reverse reaction will proceed at equilibrium. And you have to remember concentration. Okay, kepekatan of reactants and products remains constant over time. Maksudnya bila kita dah capai equilibrium, okay, bila kita dah capai tahap keseimbangan nanti, concentration of reactant and product dia akan malar. Okay, so apa ciri apabila sistem berada dalam keseimbangan? Okay, first, this one very important. Rate of forward reaction is equals to rate of reverse. Forward reaction, rate dia sama dengan rate of reverse reaction. And at equilibrium, concentration of reactants and product as well as color remains constant. So maksudnya, bila macam yang Miss explain tadi, bila equilibrium sudah dicapai, concentration akan jadi constant, malar. So maksudnya color tidak akan berubah, pressure pun tidak akan berubah. Okay, so kita akan tengok dua jenis graph. So the first graph is a graph of concentration versus time. So jangan lupa bila kita lukis graph, kena ada dia punya kepala lah. So quotient. Concentration is at y-axis, time is at x-axis. Okay. So now let's say for kita ambil siapa? Okay, kita ambil this reaction. For this reaction, hydrogen plus iodine gas. Bila dia bertindak balas dua ni, dia akan menghasilkan 2 mol hydrogen iodide. However, hydrogen iodide ni, dia akan bercerai menghasilkan semula reactant tu tadi. Okay, so now, okay, kita tengok reactant. Concentration of reactant over time, dia akan berkurang. Kenapa concentration tu berkurang? Sebab concentration dia akan digunakan untuk menghasilkan produk. So pada awalnya concentration of reactant ni banyaklah kan. So lama kelamaan dia akan turun. So sampai satu tahap dia dah jadi constant. Okay, so this curve is for reactant. Reactant kita is hydrogen plus iodine. Okay, that is for reactant. Okay, kita tengok produk pula. Produk originally dia tak ada kan. Pada awal-awal reaction, produk tak terhasil lagi. So, tapi lama kelamaan produk tu akan bertambah. So, curve dia daripada kosong, dia akan naik. Sekejap My pen ni tak smooth sangat. Sampai satu tahap, dia akan jadi constant. Bentuk dia sebenarnya macam gunting. Okay. So, ini adalah untuk produk. So, label produk awak which is hydrogen iodide. So, label kat sini juga, ini adalah initial concentration lah. Okay, so cari dekat mana graf awak dah jadi straight line, itulah tempat di mana equilibrium berlaku. Sorry saya ingat sikit. Padam balik. So this is where equilibrium happen. So kalau awak tengok, apabila equilibrium sudah dicapai, concentration dah jadi malar, becomes constant, dia dah tak berubah. So that is the graph of concentration versus time. So kalau soalan kata explain your graph, okay, so kat sinilah explanation dia. So as reaction proceed, concentration of reactant awak tengok decrease, while concentration of product increase. Manakala rate of forward reaction bertambah. Kenapa bertambah? Sebab produk makin lama makin bertambah. Rate of forward adalah kadar di mana reaktan bertindak balas untuk menghasilkan produk. So rate tu akan bertambah lah. Okay. So rate of forward akan bertambah. When I say forward reaction, it means from left to right. Kalau reverse reaction, from right to left. So this is a reverse reaction. Remember that. Okay. Sorry ya, sesama pula sikit. Okay, next adalah kat sini ya, tengok. At equilibrium, both reactants and product remain constant. Okay. Next. Bawa sikit graf ni. Okay. Next is graph of rate of reaction versus time. Okay. Reaction yang dibagi kat sini yang ni ya. Kita fokus this reaction. Okay. So as I mentioned before, sebaik sahaja once equilibrium has achieved, rate of forward is equals to rate of reverse reaction. So the graph will looks like this. Okay. Forward reaction, kena start daripada kosong. Forward reaction, dia daripada kosong. Sekejap, Miss punya ni dia tak panjang. Daripada kosong makin lama makin meningkat sampai satu tahap dia constant. So this is This is forward reaction. Okay, Miss label kat sini forward reaction. So untuk forward, daripada macam yang Miss cakap tadi lah, kalau forward from left to right. So daripada tak ada jadi ada. So untuk reverse reaction, dia daripada maximum, bengkok lah pula. Dia curve, dia akan berkurang sampai satu tahap, dia akan berjumpa dengan, yang ni dia akan jadi straight line. Okay, so this is reverse reaction. Okay, graf ni sepatutnya macam ni ya. Yang ni turun, constant. Lepas tu yang tu naik, constant. Should looks like this lah. Okay. So, this is rate of reaction versus time. Jangan lupa, where's my pen? Okay. Titik dia bertembung tu, that is where equilibrium achieve. So, you have to put ... line, label equilibrium. Okay. So now, let's have a look at the exercises. Dia cakap apa ni? The nitrogen 4 dioxide dimerized as follow. Dimerized means that change ataupun bercerai. Okay, menjadi from here to here. You are given enthalpy. So enthalpy here you can just ignore. Tidak ada kaitan lah. Okay. For next one, dia suruh sketch a graph. Kalau sketch means that you do not need a graph paper. Tak perlu graph paper lah. Okay, sketch sahaja. Showing how concentration of reactant and products above vary. Vary ni maksudnya bertukar during the course of reaction. Okay, maksudnya dia suruh awak tunjukkan perubahan concentration of reactant and product over time. So ada 3 markah. So graf yang awak akan guna adalah graf yang pertama tadi, this one. Sebab this is graph of concentration versus time. Soalan nak concentration, jangan pula you guys ambil rate of reaction. Okay, first you need, sekejap, lupa pula ada benda ni. Okay, so first you need obviously you need a x and y axis. Sekejap, I need to enlarge it. Okay, next. Okay, don't forget to label. Jangan buat saja label, letak ni. So this is concentration. You can use the square bracket symbol. Concentration versus time. Okay, time is T lah. Dia tak ada mention time dalam apa. So, biarkan macam ni je. Okay, so now we know for reactant start from maximum concentration, it will decrease. And it will becomes constant. So ini adalah curve for reactant. So awak label concentration of reactant siapa? NO2. Okay, next for product. Product asal-asalnya tak ada kan? So dia start daripada kosong lah. Okay, makin lama makin bertambah. Okay, sampai satu tahap dia jadi constant. So your label your reactant which is N2O4. Okay, dah habis lagi. Don't forget to find where the concentration become constant. Label equilibrium. Okay, now 3 markahnya kat mana? First, when you label concentration versus time, axis ni dah dapat 1 markah. Then your curve 1 markah. Final ni yang equilibrium ni, awak kena label equilibrium 1 markah. Basically kita nak bagi markah free je kat awak. So sayanglah kalau awak tak tahu these 2 graph. So to put in a summary, basically you have 2 graph that you have to know. First graph adalah graph of concentration versus time. Second one adalah graph rate of reaction versus time. So ingat, kalau yang first tadi dia graph gunting. Yang ni, concentration ni graph gunting. Okay, so let's proceed to the next one. Okay, equilibrium constant. So, for reversible reaction, at equilibrium and constant temperature, ratio of concentration of reactant and product has a constant value of K. Maksudnya, once equilibrium dah achieve, okay, ratio concentration of reactant and product has a constant value. For example, this reaction. So, the ratio is Kc equals to concentration of product. Produk awak C dengan D tau. C dengan D. Divide by concentration of reactant which is A and B. So you have to put yang kecil-kecil depan ni adalah dia punya stoichiometry. So you akan jadikan dia sebagai power. C to the power of C, D to the power of D, A to the power of small a, B to the power of small b. So, ingat, dekat atas, is concentration of product bahagi concentration of reactant. So, Kc tu apa benda pula? So, Kc is equilibrium constant in terms of concentration. C for concentration. So, kalau kita nak cari nilai equilibrium, okay, by using concentration, so we will be using Kc. So, Kc equals to concentration of product divided by concentration of reactant. However, if the reaction involve gas species, okay, equilibrium expression can be written in terms of partial pressure. Partial pressure adalah pressure is for that particular gas. Contoh, this one. Kalau awak tengok semua ni, gas phase So, kalau gas A, maksudnya partial pressure tu untuk gas A sahajalah. Okay, cara kita nak tulis expression, if your species is gaseous form, is we will be using Kp. Tadi Kc kan? So, sekarang Kp. So, konsep dia sama, product over reactant. So, the way we write is partial pressure of C to the power of C kecil times partial pressure of D to the power of D divide by partial pressure of A to the power of A times partial pressure of B to the power of B. So, yang PPP ni is partial pressure. So, remember, Kp is equilibrium constant in terms of pressure. Only for gaseous species. Okay, kalau aqueous tak boleh lah. Okay, next one. Write equilibrium constant expression for the following reaction. Okay, now let me show you the first one. A. We first study the species. So all in aqueous phase. So we will be using Kc. Tak boleh guna Kp lah sebab Kp for gaseous species. Okay. So nak tulis as equilibrium constant dia Kc equals to concentration of H plus, okay, dia to the power of 1 times concentration of HCOO minus to the power of 1 divided by concentration of methanoic acid, SCOOH. Okay, itu je. Okay, so remember, if question asks you to write equilibrium constant, dengar je perkataan equilibrium constant. Ni, equilibrium constant. Maksudnya awak kena tulis sama ada for Kc ataupun Kp. So nak tahu Kc ataupun Kp, tengok pada species tu. Tengok dia punya state dia. Okay. So yang kedua B. Okay, B is in gaseous state. So kalau gas kita boleh tulis dua. Sama ada in terms of concentration ataupun in terms of partial pressure. So, kita buat Kc dululah. So, in terms of concentration, species apa tu? Okay, carbon monoxide, product kan? Carbon monoxide to the power of 2 times oxygen gas, concentration of oxygen to the power of 1 divided by concentration of CO2 to the power of 2. So, this is Kc expression. Kalau Kp, tukar je cuma dalam bentuk partial pressure. Pressure for carbon monoxide. Cuba awak tengok beza dia punya bracket. Kalau concentration, please use square bracket. Tapi kalau pressure, gunakan bracket normal lah. Tak payah jangan guna square bracket. Nanti salah. Times pressure of oxygen. So, this is the partial pressure. Divided by pressure for CO2 to the power of 2. Okay, so that's it. You don't have to worry about the what we call dia punya reaction balance or not. Kebiasaannya dia akan bagi yang dah balance. Okay, so next one, C. Kita check dulu species. Okay, ada solid dekat sini. Okay, so for solid phase will be not included in our equilibrium expression, solid and liquid. Okay, so kenapa? I will explain to you here. Okay, here. Concentration of solid and liquid do not appear in the equilibrium constant. Kenapa? Sebab concentration of pure solid and liquid do not change much with temperature. Contohlah awak ada batu. Batu solid kan? Awak panaskan batu tu. Basically batu tu tidak akan berubah. Dia punya volume ke apa, dia tidak akan berubah. So that is why concentration of solid and liquid do not appear in equilibrium constant. Okay, patah balik sekejap. So, awak maksudnya ignore je these two. So, since dia punya phase is gas, macam tadilah, we can write two things, Kc and Kp. So, Kc equals to concentration of O2. Itu je lah. So, untuk Kp dia equals to partial pressure of O2. Okay, so for last one, D, you have solid phase. Okay, so Kp, I write Kp dulu, sama dengan partial pressure CO2 lah. Kalau Kc, concentration of CO2. Okay, so that is how we write down the equilibrium expression. Yang pentingnya, produk ke atas, reactant dekat bawah. Jangan lupa kalau ada stoichiometry, jadikan dia sebagai power. Okay, next. Okay, next, we have two types of equilibrium. Kita ada homogeneous equilibrium. Second one is heterogeneous equilibrium. So, apa beza dua ni? Kalau homo means sama. So, for homogeneous equilibrium, reactants and products are in the same phase. Same phase maksudnya fasa dekat sini semuanya sama. Okay, that is homogeneous. Kalau heterogeneous, kalau heterogeneous, reactant and product are in different phase. So, kalau awak tengok ini gas, solid. Okay, gas, solid. So, maksudnya dia punya phase tu tak sama lah. Okay, so this one I explained to you earlier. Okay, contoh homogeneous adalah kopi. Okay, contohnya kopi lah. So, kopi ni awak campur apa? Sebut kopi, susu, sugar kan. So, bila awak campur, awak nampak satu benda je kan. Awak dah tak nampak gula kat mana, kopi kat mana, susu kat mana. So, the mixture is homogeneous mixture. Yang kita belajar pada topik awal-awal dulu. Okay, another example is homogeneous mixture adalah blood. Ni, dalam blood kita ada banyak sel. So different cells make blood. Tapi kita nampak satu benda je kan. Kita nampak blood je. So kita nampak blood pula. Kita nampak warna merah je kan. So the blood solution is the blood solution adalah homogeneous mixture lah. Okay. So please complete this one. Please do these exercises. Ada 4. Submit to me through GC. Soalan suruh identify homo or hetero. Write equilibrium expression KC and KP if any, jika ada. So complete this one and submit to me through GC. Okay. So that's it for part 1. So I will continue the next one after this. Okay. So thank you for now. Assalamualaikum.